Hello. So today's topic is very much just an intro and will not go deep into anything. We'll just discuss the basics. So the main thing we are going to discuss about is what is machine learning. This is going to be our whole course, and basically what the thing is that there is a machine, let's say M, where we give an input and we get an output. So this machine is like a basically a function, you can say. So okay, so now at the end of a day we need to make this M so that when we give an input we get an output. So let's say I want to have, mm, let's say I'm giving you a picture, right? So this is a picture. You have to tell me, is it a cat or is it a dog? So this is kind of like a machine learning problem. I'll give you a, let's say, I'll say, what is 2 plus 2? So your answer should be 4. So there is an input and there is an output. Okay, so that is how we deal with this. Okay, so now we will talk about the different types. The first big type is supervised learning. Okay, so today is going to be a very introductory class. We'll not go into depth of what supervised learning is. So basically what we have is that we will have some data of xi, yi, right? So our data set will be something like D, which will have, let's say, x1, y1 till xn, yn. So this is our data set. Data set is our data. Okay, data. So what we do is that, let's say, we need to find that function fx. Okay, so find that function fx for which x will be output and y will be output, and your machine basically will work better. And in like mathematical terms we can say this is basically nothing but an optimization problem where we try to decrease the error. Okay, so of course let's say this y is there, and let's say if you had some, we know the output, okay, that would be y, and let's say this is y hat, right? So what we try to do is that whatever the error would be, it would be some function of y dash y. So we need to minimize this. So our goal is to minimize this error. Okay, this is supervised learning. And let's say when we talk about data, right? So let's say we have the data. So we have three kinds of data. One is training data, one is test data, one is validation data. So what is each of them? So let's say if I have a data block here, we break it into some parts. Let's say I'm doing 60, 20, 20. With this 60, I teach the model. Okay. With this 20, this is my train. Let's say this is my validation and this is my test. Okay. So with this 20, what I do? I check if it is learning. So like you can check in the middle with the validation ki is the model learning or not learning, and test is after the training has been done. I test, or I actually evaluate if the model has learned or not. Okay, so this function fx, we are naming it as model. Okay, so we are all going to deal with models. Now let's talk about the second type, that is unsupervised. Okay, so supervised learning is what is the case. Let's say like there will be some input and then output and you're trying to learn it, right? But here you will not have a label. So this x this X was my data and Y is its label, right? So in this case, Y won't exist. So on supervised learning, you just have X. So let's say like you have a drawer of items. Okay. So let's say you have like three colored balls, right? R, G, B. And now you don't have a label to it, right? So you're not labeling any ball. So you see the balls and you separate into R, G, B. So this is like a case. So here what you have is basically how can I separate these classes? How can I separate these classes without having any labels? Okay. And the third type, reinforced learning. So this is a very interesting thing which will not go into much depth. So you have to realize your supervised learning is 50% of your syllabus. Unsupervised learning is around 40% of your syllabus, and reinforcement learning is very less, so it's like around 10%. So this makes up your syllabus. So this is a very less part, but I'll explain in short what it does. So let's say if you have a kid, right? So you put your kid in an environment, okay? And this kid is called an agent, right? So what he does, he's currently, let's say, in the state ST, okay? He does some action AT and he is now currently in state ST plus 1, okay? So what we see is that from this ST plus 1 and ST, we assign something called a value, okay? Value or slash a reward, okay? So if it does good, I'll give it positive marks. If it does bad, I'll give it negative marks. So it learns ki matlab, for example, let's say there is a fire here and you touch it, okay? I can't draw a hand apparently, so I'll anyways try, okay? So let's say this, you're putting a hand, now you get a penalty, so you will never touch it again, right? So now let's say there is a beautiful flower and you try to touch it and it's good, so you'll get a positive reward, so you will try to touch flowers, okay? So this is like how reinforcement learning in its base works. So today's our introductory class will not go into depth of how all of this works. So I have told you about the train set, validation set and everything. So now end of the day, our goal would always be to minimize the error, okay? Everything, our goal is this, minimize the error in everything. So now we are going to talk about a different type of classification, means different like type. So we're going to first talk about classification. What is classification? Okay, what is classification is that we break things into discrete classes, okay? Simple thing. So basically, let's say function x, we are breaking it into class 1, class 2 and class n, okay? So like for example, let's say you get a mail right now, right? So it can be either, let's say, spam or not spam. So see, we are classifying it into two different classes, okay? So this is what basically classification is. So see, you can see these are two classifications. So these kind of classifications are called binary classifications. We can also have multi-class. So let's say if you have an emotion, right? So it can be happy, sad, angry, anything you want, right? So there are many things we are going to learn, like logistic regression, SVM, decision trees, KNNs, knife base, and maybe some neural networks as well, okay? So under classification, these all come. So we are going to discuss this throughout this course, okay? So there are many now, like you might even ask, how do I calculate classification? You can either find, let's say, accuracy. You have something called precision. I am just going like overview right now, so that like we'll discuss all of this in detail later. So like, we have something called recall score, we have something called F1 score. We make, from all of this, we make something called a confusion matrix. It looks like this. Okay, and this is the thing that helps us understand about how our thing happens. Okay, so these are all the terms we're going to study later on. Okay, so these things are mainly used in, for example, your sentiment analysis. This is called sentiment analysis. This is like spam, not spam, etc., etc. The second big type is going to be regression. So what regression is that we, earlier one was discrete, now we predict continuous outputs. Okay. So it's like, for example, I'm giving, let's say, my height, okay, and it will give you my weight. Okay, so it's a continuous thing. So this graph cannot be something like a histogram, right, like the earlier one. So this graph has to be some graph like this, for example. So for my height, there has to be a weight, something like this. Okay, so simply this is some y equal to fx form. Okay, so there will be many types of regression we are going to learn, like for example linear, let's say multiple, and we are going to also do polynomial. Okay, so like we can also do regression on the everything, so like the unsupervised as well. So like classification problems, like we'll have KNN regression, and like everything can be done. Okay, so usually, like in the earlier case, we were using these metrics for evaluation. In this case, we use, let's say, we call it mean squared error, MSE, mean absolute error, MAE. Okay, and something called a R2 score. So this thing is your, helps in like predictions of like some continuous value, like for example stock price. Okay, stock price is a continuous value, no? So stock ka curve, if you see, it will be something like this, right? So it's continuous, it's not like breaking or discrete. The next big thing we are going to discuss in this course is called feature engineering. Okay, this is very important. So in this you'll mainly have scaling, normalization, or let's say bad data. How do you deal with bad data with sampling and everything? Then you'll have PCA, which is basically dimensionality reduction. Like let's say if I have a data in 3D, right? So let's say this 3D data is not very understandable, and now I convert this to, let's say, a 2D data. So 3D to 2D data, and now it's like very separable. Okay, so let's say it's very separable. So we use something called PCA for doing this. And yeah, okay, after this we'll also learn about training, how these models go around training and optimization. So training and optimization will include something called stochastic gradient descent. Also we'll have normal gradient descent, basically the batch gradient descent. And yeah, we'll talk about, let's say, learning rate, what is learning rate, and what are the bias, variance, trade-off. Or let's say we will talk about regularization. I'm just giving you the topic names, okay, like what I'm going to do and everything. Okay, and finally at the end of the course we were going to do something called what? Neural networks. It's a very important deep learning topic. This is slightly there in the syllabus but also not in the syllabus, so we'll anyways cover this. And we are going to code. We are also going to code, and how we're going to code, we'll only use PyTorch. Okay, PyTorch only. And in most of the cases you'll not be using PyTorch, so except of PyTorch we'll be using NumPy and simple Python, nothing else. Okay, so you need to be proficient in this at least. Okay, so this will be a 90% of the code will be here, maybe 10% of the code here will be here, 10%. Okay, so with this we finish the introduction part. We will do the rest. We'll start with linear regression the next day.